Hi everybody. As we discussed on the Google Hangout tonight, I wanted to give you a brief overview of what the updates amount to that I'm working on the RIT style arm. What I've got here is a combination model. Um, the yellow and gray parts are the updated version that I'm working on. The transparent purple is the original design. This will help you kind of see direct comparison on some of the bulk and what's been changed and what I'm working towards. So I guess first off, you can notice all of the like the arm off of the cuff that comes up, and the all the stuff that's involved with the string system and how all that comes together up here. All that stuff is gone. The tensioner system that goes up along the top of the cuff, along the front as well, that's all gone. The block on the side that's a stop for the cable pulling mechanism is gone. Roll this around on the top. One of the things that that I've noticed with our recipients is when they bend their arm at the elbow that they tend to slide, not necessarily slide clear out, but this area is kind of loose here. So you can, if you look real close, you can see that this dark area is where the original is, and I've actually moved this portion back closer to the elbow. I believe that it's positioned so that it won't cause any discomfort if the recipient makes a full bend of the elbow. One other thing that I've seen is these edges over here are typically out too far. That adds to some of the looseness of the forearm cup. So I moved this in. As you can see right here, the inside edge of the original is in this area. I've moved it all the way in here. Again, it shouldn't crowd the elbow enough to cause any discomfort or issues. One good thing that's come from that is that it allows me to actually move the pivot bar on the tricep cuff inward. So part of the whole reason behind redesigning this cuff is to take away enough of the bulk and move things around so that this is able to be worn underneath of a t-shirt sleeve, or even in a wintertime environment, maybe underneath of a coat, within the sleeves of a coat. So that's kind of the comparisons there. I'll close this out. And now we'll take a look at the actual arm just on its own. It's missing two key features right now. One is the tensioner block that I already talked about. It ends up over here on the side and takes up a fairly small amount of the space. And the other is where the string comes up from the hand and comes over here to the pivot point. There's actually going to be a external cable routing on this forearm cup that will travel along here and make a turn and come around here, and it'll actually have a small stub build off of this that will run the string up and match in with this line here. The string will come in this line, exit out here, and go into the tensioners over here. So it's a very important feature that's not quite finished out in this model, but I can show you. Here's the Raptor wing design that I mentioned before. What I'm talking about on the forearm cup for the RIT arm is actually a small piece that comes up similar to this. So how that'll work is the strings will exit here, enter here, come out down here, and this is the two-block tensioner system on the side here. So you can see we really reduced the bulk of the tricep cuff there, and the way this works is obviously if you move this thing up and down, the string being tensioned here, it pulls on the string as it gets stretched from here. I think this whole fulcrum that I've got here gives it a little more freedom of movement, so it's not a small movement, and the hand is actually fully gripped, and the recipient's stuck with a almost straight out arm. So I guess while I have this Raptor wing open, I'll show a little more about it. I apologize for this model. This is a left-hand version, but it has a right-hand palm on it. The way this works, this palm is hollowed out and it has a whipple tree inside of it, and then it has 4 screws that hold the palm onto this piece. This piece has a cable routing up through here all the way through this whole thing and exits here, pretty much like I already explained. The design is, I guess I'd say, half-baked. What I wanted to come up with was something that could be printed out flat. As you can see, I put this offset in here so that it actually lines the hand up, and there's plenty of room for the forearm on the recipient. My intentions were to make this so it prints flat with this down, and then there will be a cutout in here for Velcro, and then there will be attachment points for some sort of a visual accessory, I guess I'll call it. If someone wants to put on a decorative cover over this to cover part of the forearm, or any sort of add-on that you might want to put on here. Certainly that was my intention of making it so that that can be done. In a side view of this, what I had in mind was we were talking about the software where everybody can come in and put in a couple of dimensions, and the Raptor hand or whatever they're making that gets adjusted out. My thoughts were that we could either make this piece in a variety of versions in half-inch length increments, short to long, or this could work with that software where the changes in length happen in the middle portion of this, so that none of the geometry on either end is affected. So that's about all I've got on that Raptor wing, but that's my thoughts on that. Come in here and do a section view of this. There we go. So now that I've sectioned this, you can kind of see what's going on. I've hollowed out the palm. This is a whipple tree in here. You can kind of see, of course, your string comes out of one finger around the whipple tree into the other. Same thing over here. The string from the whipple tree comes up and goes through this this canal here. What I've done on the thumb is actually where it comes out, I've created a slot for this to come around here, and as you can see, it's a nice sweeping radius where there's a bit of groove that the string fits into. One of the problems with trying to do this with a normal thumb is the string would come inside and have to make a direct bend, and things that tend to want to bind up and not work properly. So I made this string groove so that everything had a nice sweeping curve to come around here, and then the thumb portion comes into the bottom cable route, whipple tree comes into the top, and they both come together in one tunnel and then go into the matching area out through the forearm cup and along the outside. As I said, I have to build this portion into the model yet, and then comes around and functions through that. While I have this sectioned, I'll show you another feature that I discussed. This connector is a print-in-place all-in-one piece. It would be printed with this portion of it down on the build plate and built upright. There's enough gap between the two separate pieces that they can be printed and stick well to the build plate. And when the build's all done, you take them off the build plate. They are actually two separate pieces. So the retainer will rotate, the center will rotate, and I build in a groove for an O-ring. So the way that works is once you're done building it, you take it off the build plate, you move the retainer ring up this direction, you slide an O-ring over the end of this, and it falls into place here. And then you put this up against a Forearm Cup, and you bring the retainer up, and the O-ring is big enough that it leaves a little bit of a gap here where the retainer bolts up. Once you put the screws in and tighten it down, everything comes up against the Forearm Cup, and it compresses this O-ring. And what that does is hold the hand in whatever position it's in, but if you grab the hand and give it a little bit of a firm turn, it'll break free and you can actually rotate it. So that'll allow the recipient to rotate the hand in whatever position they want it to be, and when they stop rotating it and let it go, the O-ring will take a set again and it'll stay in place. This piece, I've designed it with enough of a let me come around here, with enough radius and curvature that this whole piece can be printed upright with no support whatsoever. Everything transitions to a smooth radius, and the way that it's built, at least on my printer, I had absolutely no trouble printing it with no support whatsoever. The palm bolts on. As you can see, I've got two screw holes in the top. I've got one on either side. There. And then there are two on the bottom. Another thing that I didn't discuss with you on the Hangout was the way that I've been working on the elastic. On this particular model, the elastic will come in from one proximal, wrap around here and go into the second one, and it'll be tied off right there. What this is going to boil down to is we can put a thicker elastic up here in the top, and then the elastic for the proximal to the fingertip, we'll use a smaller elastic. And what we can accomplish there is the adjustable grip. Basically, we're kind of like Jason was doing, juggling around the orthodontic rubber bands, a heavier one on the upper portion of the finger and a lighter one on the end of the finger. You can get where the tip of the finger will start to close sooner than the proximal to palm. So I think I've rambled on just about enough for right now. I did want to show, just so you can kind of understand what I'm doing with the Velcro out here. The way that I've designed the thing, where the original tensioners were, since they're gone, you can actually wrap the Velcro around. Everything ends up being circular. Takes all the stress and strain off of the tricep cuff, and when we come down here, and I'll do another section view so you can maybe see this a little bit better. So as we look at this view, the Velcro would actually follow this groove, come right around the top, come back around here, and then this would be the bicep area of the recipient's arm. So instead of coming in from the side on the cuff and going up over the bicep and back down and through here and then back around to tighten up, this makes a full circular method of attachment. The other method, when you tighten this up, it actually pulls the sides in on the tricep cuff, puts a lot of stress up in this area and over on the sides, and eventually the things will start to crack. This will actually, by being rounded around the bottom and follow the shape of the recipient's arm better, there's no stress on this, and it actually, I believe, will hold in place better, which is one of the complaints of the recipients I've been involved with. The combination of the weight of the whole arm versus not being attached tight enough up on the bicep tricep area allows everything to start sliding down over time. So hopefully everything that I just showed you here, once I get it all the way done, we get it into testing, hopefully those will be some valid improvements. That's all I have for now.